right, a very important skill that you also need to remember is how to rationalize numerators and denominators of expressions. So when did this come in? This came in where, if you remember, rationalizing the denominator, what did that mean? It means you can't have a square root in the bottom in your final answer. Again, this is motivated because back in the day when they didn't have calculators, they needed to rationalize the denominator to be able to solve these issues. Not such a big deal today because we have calculators to do that, but it's still an important technique algebraically to be able to rationalize a denominator. So anytime you have a denominator with a square root, for instance 1 over the square root of 2, what you're going to do is multiply both the numerator and denominator by that radical. So it's square root of 2 over 2, which would be the root 2 over square root 2 times square root of 2 is 2. So if you notice, that's the technique. If you have a single term in bottom with a square root, just multiply the top and bottom times that square root. But what happens if we have a denominator where we have multiple things in the denominator? For instance, the square root of a minus the square root of b. And that's where we do a trick that's called multiplying by the conjugate. So what's the conjugate? The conjugate is the exact same thing with the opposite sign. So if it's the square root of a minus the square root of b, you're going to multiply the top and bottom by the square root of a plus the square root of b. Multiplying by the conjugate, when you have a sum or difference with radicals, eliminates the radicals. We'll see all of this firsthand in these next problems. So let's look at 19a here. It says 5 divided by the square root of x minus 2. If you notice, I have a square root in the denominator, and the point of the problem is to rationalize the denominator. In other words, get rid of the denominator in the bottom. So what am I going to do with that? Because it's 2 terms in the denominator, I have to multiply by the conjugate. Multiplying by the conjugate is the exact same thing, but with the opposite sign. So the denominator is the square root of x minus 2. I'm going to multiply the top and bottom by the square root of x plus 2. Multiplying by the conjugate when you have multiple terms in the denominator. So let's look at this. In the numerator, what would I have? Well, distribute the 5. I'd have 5 times the square root of x, and then I'd have 5 times 2, which is a 10. Let's think about that denominator. In the denominator, you would have the square root of x times the square root of x, which is the square root of x squared, or just x is really what it is. Then I'd have, if I'm foiling it out, square root of x times 2 is my outer, so that'd be 2 root x. I'd do my inners, which would be a minus 2 times the square root of x. And then I'd do my last, which is a minus 2 times 2, which is a minus 4. Notice what happens in the denominator. Those 2 middle terms cancel out, and that's because we multiplied by the conjugate. Anytime you multiply by the conjugate and you FOIL, those 2 middle terms cancel out, which is really important. And again, the square root of x squared is just x. So really what I'm left with in this problem is 5 times the square root of x plus 10, all over. On the bottom, I just have x, 2 middle terms canceled, then I have the minus 4. So 5 root x plus 10 all over x minus 4. Nothing in common there that I could factor out and simplify, so I'm done. Very, very important there. Okay. I cannot tell you how important problem B is. In fact, a problem like B might be on your first test. Very, very important skill here. This goes to the definition of derivatives, which is one of the things we're going to be working on your first or second test. Very important that you understand mathematically how to do this problem. Here, we are not rationalizing the denominator. We actually want to rationalize the numerator. Here, we do not want to rationalize the denominator. We actually want to rationalize the numerator. Just to give you a little bit of history of why would we care about this. Imagine if we plugged in h equals 0. If we plugged in h equals 0, we would have a 0 in the numerator and a 0 in the denominator, which is called indeterminate form. It's undefined. So we can't plug in the numbers h equals 0 here. So what we want to do is algebraically manipulate this expression by rationalizing the numerator, so we actually could plug in the value h equals 0. So if we're rationalizing the numerator, we need to get rid of the radical in the numerator. So how do we do that? Well, to get rid of the radical in the numerator, multiply by the conjugate. Because there's 2 terms, we have to multiply by the conjugate. So it's going to be the square root of x plus the square root of x plus h. On the bottom, we're going to have the square root of x plus the square root of x plus h. Okay. On top, we are going to FOIL it out on bottom, I do not want you to do anything. I want you to always leave your denominator in factored form, okay? So on top, what do we have? Well, if we multiply the first, foiling it out, first would be square root of x times square root of x, which is the square root of x squared, or quite simply just x, okay? Outers would be plus the square root of x times the square root of x plus h. Inner would be minus the square root of x times the square root of x plus h. Remember, I flipped the order there, but I just wanted them to look the same. Square root of x plus h times square root of x is the exact same thing. You can flip the order with multiplication. And then the last one, be really careful with this, I would have minus the square root of x plus h quantity squared. And we got to be really, really careful with this, because when we do the square root of x plus h squared, that's really just x plus h. But again, be very, very careful. Make sure you use parentheses there. We are going to have to distribute the negative on that one. So on bottom, leave it in factored form. So this is x times the square root of x plus the square root of x plus h. Take a breather, take a look, see what you just did. All we did was FOIL out the top. Again, the square root of x squared is just x. The square root of x plus h squared is just x plus h. If you notice on top, the whole reason we multiplied by the conjugate is both of those two middle terms are going to cancel. Anytime you multiply by the conjugate and FOIL out, those two middle terms cancel. So let's see what we're left with. On top, we would have an x for the first one. Then we'd have minus, and I'm just going to emphasize this by using parentheses, minus x plus h in parentheses. Please, please, please be careful with that. On bottom, we have the h times square root of x plus square root of x plus h. Distributing that negative, we would have a minus x and a minus h. So we really have x minus h all over h times the square root of x plus the square root of x plus h. Notice on top, those negative x's, x minus x, actually cancel. So here I'm left with a negative h all over h times the square root of x plus the square root of x plus h. But now, only now that those x's canceled, I have an h on top and an h on bottom that are factors, so only now can I simplify those. I can't do two steps in one. A lot of students like trying to cancel the h's in the previous terms, but you cannot mathematically do that because it's not a factor, and remember, you can only simplify factors. So here I'd end up with negative 1 over the square root of x plus the square root of x plus h. Looks crazy, I know, but that's what it is. This algebra is huge for you, absolutely huge. If you go back to the motivation of the problem, I told you, what if we plugged in h equals 0? Well, if we plugged in h equals 0 to the original problem that we had, we would have had square root of x minus square root of x on top, which is 0, and a 0 on bottom. So we would have 0 over 0, which is indeterminate form and undefined. Look at the final answer here. What if we wanted to plug in h equals 0 for that one? Now all of a sudden it's defined. It would be negative 1 over the square root of x plus the square root of x, which is negative 1 over 2 times the square root of x. So I don't know if you know what you just did, but you just found the derivative of square root of x. Again, this is something we're going to be doing within the next week or two of the class, but very, very, very important algebra. You are going to see this exact problem done again and again this semester. So please take a look at that and make sure you understand it.